Hello, welcome to this video. I'm Adrian Niodusawa and this is the fifth video of our introduction to computer programming with Python. I hope you enjoyed this video and let's get started. So in the previous videos we talked about all these 12 parts of programming, and in this video we will talk about these blue ones and we have the black ones remaining for the forthcoming videos. Now quickly moving, today we will take a look at the two-dimension nested lists and the nested loops. We take a look at the list comprehension and we end with try except block. Now what is a 2D nested list? So it is basically a list or lists which are placed inside another list. So every time we have a main list here and we have small lists which are inside the main list. These are the small lists inside the main list. That makes it a two-dimension nested list. If you had if this inside list were also lists, if the item were also lists, then it would become a three-dimension nested list. But for the purpose of this course, we stick with 2D. So notice that we can represent it in this way or this approach, which is not different except that we are simply breaking a line after every list item to increase the visibility. So both ways are acceptable. And we can use matrices to represent tables. This table here, which is how it looks like in Excel, can be represented in this way in our computer programs. Notice that we have two rows, and the rows are equivalent to sublists in our two-dimension list, and we have 4 columns: 1, 2, 3, and 4th column. These columns correspond to the items inside the sublist. So we have the first item, second item, third item, fourth item. So every sublist is a row, every item inside the sublist is a cell. Now with that idea in mind, we can count rows by counting the total number of sublists inside the main list. And we can achieve that by simply checking the length of matrix, because the length will give us how many items are inside the main list. And for now, as you see, the number of items, it will be how many sublists are inside the main list. So the length of this matrix will give 2, and that's the number of rows. To calculate the number of columns, we need to grab one row and figure out how many columns does it have. So I grab one row here, specifically the first row, and I check the length of this first row because it's a list itself. So assuming that all the rows have the same number of columns, then I can assume that the length of the first row is going to be the same length for all the rows. So the number of columns is how many items do we have inside the sublist. Now programmers like to use M and N to represent the total rows count and total columns count. M is usually used to represent how many rows we have, and for how many columns we have. Now there is no rule to do this, it's just something which ends up being so popular. So if you have a table like this, we can calculate the number of rows and save it to M. So M is equal to the length of table, which will count how many sublists we have, which is 2. And N, the number of columns, we grab the first sublist and figure out how long it is. So it's gonna give us 4, which is gonna be N. So this will be a 2 by 4 table. 2 rows, 4 columns for every row. How do we access items in a two-dimension list? As we saw for the one-dimension list, we used an index to access the elements. For a two-dimension list, we also use index, but now we need to specify 2 indexes. The first index specifies which sublist do we want. In this case, the first index is 0, which says, okay, I want the first sublist. The second index goes inside the sublist and specify which item we want. So we want the first item inside the first sublist. So this will give us 2. So it's basically saying go into the first row and into the first column, which is this number here. Now that's how we get one item from a 2D nested list. Now what if we want to go through all the items in a 2D nested list? So we can use something called the nested for loops, and these are basically one for loop which is placed inside another. And you can think that the reason why we need to do that is we need one loop which goes through all the sublists. So it goes through the sublist and then goes to this one. And as we go through the sublist, we also need another loop inside that one which will go through the items in one sublist. So the first simplest approach is for sublist in a table, and then we run another loop which goes for items in sublist, and we can do something with the item. So the simplest way we do it in Python, but the limitation to this approach is we can only view these items, we cannot edit them, we cannot perform modifications. You cannot say, okay, item plus equal to 10, you cannot change the value like this. If you want to do some modification, you need to get the actual indexes, and we saw this in the previous course when we were running two approaches to loop through a list. And if you don't feel comfortable with it, you can quickly check previously how we run a for loop on a list, and you will see these two approaches which I'm explaining now. It's the simplest approach. Use it if you only need to view items. The second approach, which is more practical and more powerful, is using the actual indices to access items. So we use the index for the row, index for the column. So remember that we count for 0 every time. The outside for loop will go through the range of 0 up to the number of rows. The inside loop will go from 0 up to the number of columns. So automatically we need to find how many rows do we have, save it to m. How many columns do we have, save it to n. In this example, m will be 2 because we have 2 sublists. N will be 4 because we have 4 items in one sublist. Now, having this information of m and n, we can loop through the range of m, which means going from 0 to 2, because we know that every number we pass by will be representing a valid index of a row in this table. 0 is representing this sublist, 1 is representing this one. And now, as we go through that row, we can also use another for loop to go inside it and check all the items. And for that we can use the range of n, because n is representing all the numbers in range of n are representing items indexes in this sublist. So inside one row, I will run another for loop which goes through all the columns in that row. And to go through all the columns is equivalent to going through a range of 4, a range of n, because n is 4, basically we calculated here. Now, at this point, I have the coordinate row, coordinate column, and these two coordinates are enough for me to determine which cell I want to be in. Remember, in Excel, you usually have something like 1 here and something like A here. And the cell will be, they will say, okay, it's in maybe 1A. I'm not sure exactly if this is what they do, but it's something similar to this. And if you have information of 1A, you will know, okay, I need to go in row 1, column A. Similarly, in our example, we use row and column. Row is telling us which row number we need to be at, column is telling us which column number we need to be at. So what we will do is we will use these coordinates to obtain the number. And I have a small issue here. Okay. Now, if we have the row and column information, and now I notice that I need to clean up a little bit, it's messed up. Yes. So now we have the row and column information. Now we need to make a use of this information. So if we grab our two-dimensional table and we go into the row, which is represented by the current numbered row, and inside that we also go into a specific column, we can grab a specific item, and then we can do anything we want. We can view, we can just print it, we can modify it, we can perform any possible modification we want to do. And now notice that if at the end of these ropes, if we print table, it will have been changed. Every item will have been incremented by 10. With approach 1 we could not do this. You see, we tried to do it, and after printing there was no change because there's nothing, none of the item was modified. So if you want to modify, you definitely need to have the indexes. The second topic is list comprehension. So it's a very amazing feature in Python, and it is a smart and concise way of creating lists by iterating through iterable object. So imagine I wanted to create a matrix like this. I could go ahead and type it, I can hard code it, but what if now the matrix was like 1 million rows wrong or 1000 columns? Then I would need several days to be able to type it. But if you observe carefully, these items are coming in a specific predictable pattern. So we are incrementing by 1, going left, and then we are repeating the same thing. So this is, you can see that you can suspect that there has to be a way to generate it automatically. And I'm going to introduce you to how we would do it without list comprehension. So what you would do is, if I need to create a two-dimensional matrix, I will begin with an empty matrix, and then I will create one row, like this row, and I will append it to my empty matrix. I create the next row, I append it to my matrix, like that, until I finish it, which is basically what I did here. Here, if we ignore these two sentences for a while, just forget them for a while, we create an empty matrix, we go through a range of 5 because we need 5 rows, and for every number we are at, we are creating a sublist and appending it to our matrix, and we are repeating that 5 times, so we have 5 rows. Now this part now, which I said, now let's now focus on this part which is saying for j in range 5, sublist is append j. Now every sublist we need to add items inside it as well, and to do that we use another for loop, which will again go through the range of 5, and it will be appending every number to the sublist. So we create a sublist and we append it to the matrix. We create a sublist with these 3 lines and we append it in the next line. Okay, these 3 lines are creating a sublist. Initialize an empty sublist, go through a range of 5, appending every number to the sublist. And once you have the sublist, append it to the matrix and do that 5 times and you will have a matrix. This will basically produce this matrix we have on the left side. But is there a concise way to do it? And that's where the list comprehension comes in. So the idea of list comprehension is, I will create an empty matrix. Let me actually go ahead and quickly show how I would do this from scratch. Or I think it's rather visible here. So you see, we say like, okay, we need, first of all we need to define how we want to create our row. So we saw that we're building one row here and then appending it to the matrix. So the list comprehension does the same thing but in a more concise way. So this part here, you will notice that it's an inside list which is inside the main list. So this inner part, we will use it to define how we want one row to be built. And then the outside code here will be specifying now how many of such rows do we need. In this particular case, we create a row like this. We say, okay, we want our row to have what? We want it to have core for core in range 5. So for everything in range, for every number in range 5, that number itself will be the item we keep in our sublist. So our sublist will have number for every number in range 5. So it will be 0, 1, 2, 3, 4. Now this part here will be one, is how we build one sublist, or a column rather. Now, having built one sublist, now we need to specify how many of such sublists do we want to build, and this is where this part comes in. This is saying for row in range 5. That means for every number which is in range 5, we will repeat this part, and we put the whole thing in one overall matrix, which is why we have this outside brackets. So a quick recap: this part builds a row, this part specify how many of those rows we need, and there's a cross arrow on the next slide, which is what we have here. You see, we have how many rows? 1, 2, 3, 4, 5. So the outside statement will say for row in range 5, because that's how many rows we need. Now what about every single row? How do you want to build it? We can make it empty, and it will create an empty list for all those 5 rows. But if you want something better, we can say, okay, if I look closely, every row is made of numbers from 0 to 4, which is basically again the range of 5. So why can't I say, okay, now for every number in the range of 5, save it to the sublist? And the concise way to do that is saying column for column in range 5. You can always use a different variable name. I used column here. You can use I or j, it doesn't matter. So column, so column is what we store in our row, and we do that for every column in range 5. So this part will be the row, and this part will specify how many rows we need. So it's basically 2 for loops, but which are put together in a quite a smart way, and it makes the code very concise, because you see we had like how many lines of code here? 1, 2, 3, 4, 5, 6, and it's replaced by just one line, which as you become a better programmer is even more understandable than this one. Okay. Here I have a few more examples on list comprehension. Here I wanted to create this matrix, and as you see, the outside part needs to create 4 rows. That's why I said for I in range 4. Now for every row, how do we want to build it? We want to build it with numbers in row in range 3. So I said j for j in range 3. This part builds one row, this part builds all the rows. Okay. In the example down here, I am showing you that we cannot only bring j as a row number in range of 3. We can perform several operations. Like here I'm saying, okay, now I want to a square of j for every j in range 3. So in range 3 we have 0, 1, and 2. 0 I square it, it's still 0. 1 I square it, it's still 1. 2 I square it, it becomes 4. And I'm building my row like that, and I can do that 4 times. Here I use the special thing called underscore, and it's basically used when you don't need an actual variable name. So it's kind of like an anonymous variable, because I have no need for this variable name. It's just telling, I just want to tell my program how many times I want to repeat this statement. And here I did something which is maybe not the standard way of writing list comprehension, but if I wanted a matrix of just zeros, I could create one small list which has just one item of 0, multiply it by a number of how many of such zeros I want inside my row, and then I will do that for every number in the range of 4, and it will create 4 rows. This should happen as you practice more, and you will end up living this. Once you go with list comprehension, there is no going back. Now the next topic is try except broke. So imagine, how do we tell our programs how to behave when errors occur? Now I have 2 situations here to think about. Imagine you wrote a code that does division from the user inputs and they enter invalid inputs or zero denominator. In this case, the code actually breaks. And this is the one part I think it's incredibly important that I actually go ahead and show you an example. Okay, so the example I'm going to begin with is the standard division example. So suppose I had my program which used two variables. Maybe let me write a quick function. Divide, which takes variable a and b, and it will find the answer. Maybe answer is equal to a over b, and it will print some statement. Maybe, hey, I found the answer, and then it will return answer. Okay, now what if I go ahead and actually invoke this function and pass in normal numbers which does not have any error? If I run this function, it will tell me, okay, hey, I found the answer, and it will give me the actual answer, which is 2. Now, notice what happened when I put 0 here. When I run it again, I have an error, 0 division. And notice that this statement was not printed. Instead, the program broke when it reached this error. It tried to divide by 0 because b is 0 in this case, and there was an error because you don't divide by 0 in math. So when it met this error at this line, it was not able to progress any further. So everything behind this line was ignored basically. So how do we overcome this issue? So the way we do this is using something called the try except block. Notice what happened if I use the try except block. So to use the try except block, you basically write the keyword try and you press what you want to verify inside the block by using indentation. This means try dividing these numbers and saving the answer to the variable answer. Now you write a statement called except, which says what happened when there is any error in that operation. So for simplicity, I'm going to say, okay, if there is an error, now what should I say? Okay, I should say maybe print there was an error. And now I notice that this statement should be inside here, and since I'm returning answer, it's best if I set answer equal to this string. Now it's a very weird way to return integer here in one case or a string in another case, but I just want to demonstrate how this could save the program from crashing. So now when I pass in normal numbers, 4 over 2 should be fine. So if we run it now, we get, hey, I found the answer, and it returns 2, which means it tried this operation and there was no error, so we printed this statement and we jump to the part after except. Since there was no error, we didn't bother going inside here, so this was not printed. We didn't get this as the answer. So it means when there is no error, we do what is inside the try block and then go outside this whole try except blocks. Now what if there is an error? If I put 0 again here, remember the program was breaking. This time it's not breaking. Instead it's telling me there was an error. So if I have another thing here, if I have so many other codes here, they will be executed as well without any problem. You see how it was printed and then we returned there was an error. So basically the try except block is how we tell our program how to behave when there is an error. Now there's another third part to this try except block, which is called finally. What finally does is it tells the computer what to do regardless of whether or not there was an error. So if I say finally print done, what this will do is when there is an error, it will print done and say what happened. When there is no error, it will still print done and say what the answer was. So the block inside finally will be executed whether or not there was an error. So this is executed if there is no error. This is executed if there is an error. This is executed whether or not there is an error. Now I don't use finally too much. I often find myself using try and except only because I can simply write my other code outside the whole block. And I think we covered this already now. The try block lets you test the block of code for errors, and the except block lets you handle the errors, and finally lets you execute the code regardless of the result. Now you can specifically check for some common errors, like the name value error, which is where you are trying to use a variable which you have not declared, or the zero division error, which is the one we saw. So when you specify the type of error, this message will be displayed only if we have that error. So if b is 0, we will get this message. But if there is any other type of error, this except block will not handle it. The program will not do anything. Now, what you can do instead is something clever like here. You can check for the specific errors which you know are likely to happen in your program. For example, here we're checking for name error, and we can write a general except statement which will be executed if any other error happens. So if name error happens, this will be executed. If any other error happens, this statement will be executed. There is also something called an index error, which is simply where you are trying to access an index which is not available in a list. So the maximum index here is 2, but you are trying to access 9. So you can give a useful message which tells the user that the index error happened. And now finally we have a practice problem here. Suppose you had this as a map of COVID-19 cases in a particular country, and the coordinates in this matrix are representing x and y coordinates. So suppose this is a country, and if we trace some xy coordinates, now this is weird, but for every coordinate there are the number of cases we have in this region, and something like this. Now for coordinates, for example 0 0, which is weird because the country should be all the way here, but for the path here, for the location which is at 0 0, they have 13 cases. For location which is at, I believe this is how much, 1 2 3 4 5 6 7, so the row is 7. So for the location which is at 7, the number of column, I think it was 11. This location will have 49 cases. So there is 49 cases in this area. No, it's hard to draw with a mouse. Okay. Now what you are asked to do is, can you write a function which will receive this map, and it will go through it and it will find the worst hit location. So in this example, the worst hit location is this one. So it would return 0 11, which means it's at the row 0 column 11, or in other words, x coordinate 0, y coordinate 11, and also it should return also the number of cases, which is 89 in this case. So I have a plan to guide you here, and I basically went ahead and solved this practice problem. I won't go so deep into the code because this video is already long enough. Instead, read through it and try it, and if you feel like you understand it, try these two other problems. So this is also the second homework problem, which I think is really interesting. Try it, and then as a review, we talked about nested list and nested loops, we talked about list comprehension, and we talked about try except block. So congratulations on completing the 5th week of our programming class, and I hope to see you in the next videos. Like this video and share with your friends to help them learn, and subscribe to my channel to not miss the next week's content. Thank you so much.